Hi lads, so we're just back to our probability there. So this is just carrying on from what we would have done yesterday. Okay, so we did example number 4. Let's look at example number 5 for today. So a passcode consists of 4 numbers from 0 to 9 inclusive. How many different passcodes can be formed if there are no restrictions and repetitions are allowed? So if repetitions are allowed, I'm going to do my 4 boxes because there's 4 numbers possible. So for example, if you think of maybe your PIN number for your bank or something like that, that would have 4, but I don't think they'd allowed you to have something like 0000 because it would be very easy to guess. But let's have a look at this one. There are no restrictions and repetitions are allowed. So how many options do I have in the first box? 10 by 10 by 10 by 10, because you're allowed to repeat your number. So that comes out to be 1,000. The next one, there are no repetitions allowed. So again, if from 0 to 9 inclusive, that is 10 different digits. All right, so you have 10 choices in the first box. I would like boxes here, by the way. And then by 9, by 8, by 7. Why is it going down? Because no repetitions allowed. If I've used one digit, 1 is gone. So now I have only 9, by 8, by 7. It's reducing down. The next one, the number is odd and no repetitions are allowed. Okay, so if you think about it, how do I make a number odd? Is it the starting number or the finishing number that makes it odd? It is, of course, the last number. For example, like 13, 15, 17, 23, 27, etc. It's the second number, the second digit, or the last digit, really. So looking here at part C, if it's odd and no repetitions, okay, so when it's odd, I'm going to fill in the last box first. The last box is the most important one. How many options do I have for the last box? Well, to make it odd, it could be 1, 3, 5, 7, or 9. So I have 5 different options for the last box. Okay, so one of the digits is gone. How many are left? There's 9 by 8 by 7. Okay, this is part C done. On to part D. The number is even and repetitions are allowed. So if it's even, the last number could be 0, 2, 4, 6, or 8. So that's 5 options here. Okay, you only have 5 options here. Repetitions are allowed, so you can have anything you want in the first 3 boxes, but the last one has to be one of those 5. And the last one, the number is greater than 6,000 and no repetitions are allowed. Okay, so if it's going to be greater than 6,000, is it the first box or the last box that's important? Well, if you think about it, if it's to be greater than 6,000, what does it have? Can it start with a 1? No, because that would be 1,000. Could it start with a 2? No. 3? No. 4? No. 5? No. 6? Yes, it could start with a 6,000, okay, and no repetitions. So I have the first boxes I fill in first. That could be 6, 7, 8, or 9. That is 4 options in the first box. And it's no repetitions. So one digit is gone from my 0 to 9. One of them is gone in here. It could be 6 or 7 or 8 or 9, any one of those. One of them is gone in there. So how many is left out of my total? 9 by 8 by 7 and multiplying out to get your 2016. I do want boxes to see. I want to see boxes in your work, please, lads. Okay, and today's work is page 181, question 13 to 24. Drop me an email if you're stuck on any of them. They're quite short, and make sure you're drawing out your boxes. Okay, thanks, lads. Best of luck with them.